welcome to my channel. So in today's discussion, we'll basically talk about some of the internal interview questions of Python. So let's get started. So first question that you expect is what is Python and what are the benefits of using Python? So we could answer like this: Python is a highly interpreted general purpose programming language. It emphasizes readability with its use of significant indentation. The benefits of Python includes easy to learn and use, okay, extensive standard library and readability, support of multiple programming paradigms like procedural, object-oriented, functional, dynamic typing, and memory management, large community and its support. So readability and simplicity, what does it mean? Like Python syntax are clear and easy to read, which makes it an excellent language for beginners. It, its readability also makes it easier to maintain and update code. Okay. Extensive standard library is actually means that Python comes with a vast standard library that provides modules and functions for various tasks such as file input output, system calls, web browsers, and more. This reduces the need for writing code from scratch. Okay, then obviously it supports multiple programming paradigms. Okay, and like Python has a large and active community that contributes to a rich ecosystem of third-party libraries and frameworks. This includes libraries like data analysis, for example, pandas, okay, machine learning, okay, TensorFlow, web development, Django, Flask, and more. And obviously it's an interpreted language, okay, which means that you can run and test your code without the need of separate compilation step. Okay, this accelerates the development of process. Okay, and there is a also a concept of like dynamic typing. So in Python basically uses dynamic typing, which means that you don't need to have to declare the type of the variable. Like in Java we normally provide int x or string x, right? We don't need to provide the variable type. Okay, that's why it is called as dynamic typing. So this basically speeds up the development and makes the code more flexible. Okay, and apart from that, extensive frameworks and libraries, for example, web development, Django, data science and machine learning, NumPy, pandas. Okay, automation you can use Selenium, and then game development you can use Pygame. Okay, and it also supports strong support for integration, rapid development, and prototyping. Then obviously cross platform compatibility, which I just talked about, and also there are good documentation and tutorials. Okay, so in conclusion, Python is a combination of simplicity and virtuality, which is a rich ecosystem that makes it powerful tool, okay, for developers across various domains. Okay, now its readability and extensive standard library is actually quite beneficial, and it accelerates the development process and reduces the time to need for bringing up the project to completion. Okay, so if you're using Python for your projects like building web application, analyzing data, development, machine learning models, so it's actually a good choice because of its robust features. Now next is what is PEP 8 and why it is important. PEP 8 is a Python enhancement proposal that provides guidelines and best practices on how to write Python code. Okay, it is important because it promotes the code readability and consistency across the Python community. Next question is, which is very commonly asked, what is the difference between deep copy and shallow copy? Basically, in Python, copying objects can be done in two ways. One is shallow copy and deep copy. So you need to understand what is shallow copy. So shallow copy is basically of an object is like creating an object whose contents are references to the original objects. In other words, the copy of a new container. Okay, the copy is a new container, but it contains references of the same items as the original container. So like in list, when you're creating, you can reference the original content and that will create a copy of the new container. Okay, so whereas in deep copies, basically it creates a new object and recursively copies all objects found in the original. So you can see like in deep copy you will get the same result what is there in the original list. Okay, but in shallow copy it will be different. It will be it will return the referenced object, and it will not be same as the original copy. Okay, so in terms of personal like performance considerations, shallow copy is faster because it only copies the reference to the objects, whereas deep copy is slower and more memory intensive because it creates copies of the nested objects. So in summary, like shallow copy copies the outer object but does not copy the nested objects. Okay, whereas deep copy copies both the outer and the nested objects. Okay, like as I mentioned, performance by shallow copy is faster and deep copy is slower. Like next question is, how is memory managed in Python? So Python uses an automatic memory management system that includes reference counting, garbage collection, pymalloc and arenas, stack and heap, and preventing memory leaks. So like memory management in Python is actually uh, involves separate components and mechanism. Now, first is memory allocation. Memory allocation, like Python manages memory using a private heap that contains all objects and data structure. Okay, so we also heard this term in Java also. It also contains heap. Python also contains heap. The management of this private heap is ensured internally by the Python memory management. Okay. Next is like object like reference counting. As I mentioned, Python uses a simple and straightforward memory management technique called as reference counting. So in this case, what happens is each object maintains a count of references to it. Okay. Next is garbage collection. Garbage collection is a very common term that we also heard in Java. It is also in Python also. So it automatically frees object by destroying the unused objects. Okay. Okay, so next is memory pools and arenas. So pymalloc. So first is, what is pymalloc? Python has its own allocator called pymalloc. Okay, optimized for small objects. It maintains a memory of it maintains a number of memory pools for objects different sizes to handle frequent allocations and deallocations. And what are arenas? For large objects, Python uses memory areas called as arenas. So in arena, an arena is basically a large chunk of memory, okay, usually 256 kilobytes, from which memory manager allocates pools, okay. And I have already discussed stack and heap memory. So heap memory is like is used for dynamic memory allocation, okay, and it is managed by Python memory manager. Next is memory leaks. Memory leaks can occur if there are like reference to objects that are no longer needed. Okay, so that is already handled by garbage collector. So memory leaks basically is to ensure that no unused objects are present. Okay, that's how we can prevent the memory leaks. So in summary, reference counting is there, garbage collection, pymalloc arenas, keep and heap, and preventing memory leaks. So these are the ways Python manages the memory. Okay. So, in summary, Python memory management is a combination of automatic memory management features and efficient allocation strategies that ensure that memory is used effectively and freed when no longer is needed. Okay. Next question that you can expect is, what is the difference between list and tuples in Python? Very commonly asked questions. Okay, list and tuples. Okay, list and tuples are both sequence data types in Python. Um, but there are several key differences. First is mutability. Uh, like lists are mutable, tuples are immutable. That means you cannot change the tuples. Okay. So here immutability means once tuple is created, you cannot modify the elements. But in list, you can modify. Okay. Next is syntax. So list is different. List is basically defined by using square brackets. Okay. And in tuple, it's like parenthesis, using parenthesis or just a comma separated sequence. Okay. Tuples. Performance wise, tuples is generally faster and more memory efficient, while lists are slower than tuples. because they are mutable and have more overhead to dynamic resizing. Okay, so like use cases could be list like used when you need a collection of items that may change, such as collection of related objects, while tuples is basically used like when you need a collection of items that should not be changing. For example, fixed data records in dictionaries. Okay, while in case of methods, as I mentioned, like lists have variety of methods for adding, removing, and modifying elements like append, extend, insert, remove, pop. These are normal methods in lists, while tuples have a limited set of methods, mainly for counting and finding elements like count or index. Memory efficiency. Okay, another point is like list require more memory due to its dynamic resizing and because it's mutable, whereas tuples like it's memory efficient as they're immutable and have fixed size. Okay, next is use cases. As I mentioned, list of collection of items that change tuples for fixed collections. Dictionary keys, tuples can be dictionary keys, lists cannot. Okay, so in summary, mutability is the option where you can say that lists are mutable, tuples are immutable. Syntaxes, as I mentioned, performance are tuples are more faster. Methods, lists have more methods for modifying data. Use cases, lists are collection of items that changes. Tuples are fixed collections. Dictionary keys, tuples can be dictionary keys, lists cannot. Okay. Next question is, what are Python decorators? Very common and very important questions for interview. So decorators in Pythons are like a powerful and elegant way to extend the behavior of functions, okay, without changing their code. So it's like creating a functions and then calling and then putting another function inside that. That is like a form of decorators. Okay, so it's like a decorator is a function that wraps another function, allowing you to add functionality before and or after the wrap function is executed. Okay, so how decorators normally work? Decorator takes a function as an argument, adds some functionality, and returns a new function with the added functionality. Okay, so like function decorators, like it can modify functions. Class decorators can modify classes. These are the types of decorators: functions and class decorators, and they are used for logging, access control, caching, timing, and many other purposes. Syntaxes like decorators are used for add decorator name syntax above the function definition. So when you are writing a function, just you can put the decorator name like on the top of the function to basically call that function. Okay, so we can conclude like this: like decorators are a way to modify or enhance the behavior of function or methods. Function decorators can modify functions. Class decorators can modify classes. They are used for logging, access control, caching, timing, and many other purposes. And add decorator name is a syntax that you can use. So decorators can provide a clean and readable way to apply common patterns and behavior across multiple functions. Okay, it is one of the best feature in Python, which normally makes it more useful and makes Python very popular. Okay, because you can call one function inside another function. That is very popular. What are Python modules and packages? So in Python, like a module. So what is module? A module in Python is simply a file containing Python definitions, functions, classes, and statements. Okay, it allows you to basically logically organize your Python code into reusable blocks, which can be imported and used in other Python programs. Okay, modules helps in better structuring of the code and avoiding name clashes. Okay, now what are the basically like uh, what are the basically to create a module you basically type you typically write like Python code with .py file, and then using a module you can use import statement on the top of the function to basically import and use functions or variables defined in the module. Okay, so you can import specific function. Okay, for example, using from module, then import particular method you want to import. That's the way you normally import. Okay. So, what are Python packages? Packages in Python is a way to structure Python's module and namespaces by using dotted module names. Okay. So it allows you to basically organize modules into hierarchical directories and subdirectories to make them easy to use and import. So packages are basically containers of modules, and they provide the way to manage and distribute Python projects. Okay. So in summary, like what are modules? Modules in Python are files containing Python definitions and statements. Okay. And packages are the namespaces. Okay. That contains multiple packages and modules themselves. Okay. So as I mentioned, a package is essentially a directory that contains specific file named init.py, which can be empty or can contain initialization code for the package. Okay. Now the package basically helps in organizing and managing Python code into reusable components and hierarchical structures. So importing feature, as I mentioned, you can use like from class name import, and then you can use particular method you can import for that class. Okay. So importing basically allows you to use functions and classes defined in the modules and packages in your Python programs. Python modules and package system facilitates modular programming, code reuse, and better project organization. Next slide is how does exception handling work in Python? Very common question. Exception handling in Python is actually managed through the use of try, except, else, and finally blocks. These constructs allow you to handle errors gracefully and maintain the flow of your program without crashing. Okay, so like common type. First we should know like what are the type of errors we normally face in Python. Like errors could be like type error, zero division error, name error, value error, index error, file not found error. And so these exceptions can occur due to various reasons such as invalid user input, or if you are like written something like division by zero, okay, accessing an undefined variable, or trying to access an index out of range. Okay, then we can use mention something like try except block. So to handle this exception, we can use like Python has provided us like a try except block. Okay, so try block. What is a try block? This is where you normally place your code that you want to monitor for exception. If an exception occurs within this block, Python looks for an except block that matches the type of exception raised. Okay. Now, except block. What is an except block? Except block. If the exception is raised matches the expected exception type, then code inside the except block is executed. Okay, you can optionally capture the exception object to inspect details about the exception. Okay, and there's an else clause also. Like you can use else clause to execute code that should run if no exceptions raised in try block. Okay, and the finally clause. Normally in Java also we mention like finally block is will always get executed. In Python also there is a finally block that will always get executed no matter like if there is an exception. Okay, so finally block always allow you to execute cleanup code regardless on whether an exception is raised or not. It is executed whether an exception occurred or not. Okay, now so in summary, exception handling in Python basically allows you to gracefully handle errors that occur during the program execution. It helps in preventing program crashes and provides mechanism to recover from unexpected situation. Okay, understanding and implementing proper exception handling improves the readability, reliability, and robustness of the Python application. Okay, next is explain the use of self keyword in Python. Self keyword is used to refer to custom instances of a class. Okay, this is typically the first parameter of any method defined in the class and allows you to access and modify attributes or invoke other methods in the same object instances. Okay, so the purpose of self is to is it's like for instantiating method access. Okay, for like when defining methods within a class of Python, the first parameter that every method should accept is self. This is similar to like this in Java, but here the difference is every method in Python should have a self. But that is not the case in Java, where this you don't need to use this in Java in every method. Okay, but in Python, self is mandatory for every method. Okay, so self parameter refers to like instance of the class itself. By using self, you can access instances, variable, and methods defined within the class. Now, instance attribute access. Instance variables are accessed within the self, within the class methods. They are unique for each instances, okay, of the class and store data that is specific to that instance. Now, method invocation, like using self, you can call other instance methods from within a method the same class. Similarly, constructor init method. The init method is actually a constructor in Python. Similarly, in Java, there is a constructor or concept also in Java. So init method is a special type of method in Python that classes that initializes new instances of the class. It is called automatically when a new object of the class is instantiated. Within init self is used to set up initial attributes of the instances. Okay, so if you have created an init method, you can use self to instantiate your classes. Okay, just like we use this to instantiate the attribute, right? Similarly, in init method, you can use self to instantiate the attributes of the instance. Okay. So in conclusion, like self keyword is a crucial in Python classes as it allows proper instance attributes and method access within the class. Okay, it distinguishes instance methods from the class methods and provides a way to manage and manipulate data specific to each instance of the class. Understanding how self works is fundamental to for effective object-oriented programming in Python. Okay, what are init and del methods? So init and del methods in Python are special methods, also known as magic methods. Okay, they are used to define the control of behavior of instances of a class during their creation and destruction. Okay, init method is a constructor, as I mentioned earlier. Init method is a constructor in Python classes. It is automatically called when a new instance of the class is created. This method allows basically users to initialize the instance's attributes and perform any steps required when an instance is created. Okay, so for example, purpose is like during initialization purpose, init is used to initialize instance attributes. Default values, you can provide default values for parameters in init using self keyword. Okay, similarly, adding initialization. Besides initialization attributes, init can perform any other initialization tasks such as opening files and setting up database connections. Okay, del method next is the del method is a destructor in Python classes. It is automatically called when an instance of the class is about to be destroyed. That is when this garbage collected. This method allows you to clean up the resources such as closing files or network connections when an instance is no longer needed. Okay, so basic purpose is for resource cleanup. So primary purpose of del is to perform cleanup tasks. Automatic resource management. So del ensures that resources are released automatically when an object is deleted. Okay. Now, so in summary, like init method initializes the instances of the classes, setting up any required attributes or resources. Del method actually cleans up the resources when an instance is about to be destroyed. So proper use of these methods ensure that resources are managed efficiently and errors are minimized in the Python programs. Next is what is global interpreter lock? It's very common questions. So GIL is a lock that protects access to Python objects, like preventing multiple threads from executing Python bytecodes, okay, at once. It simplifies memory management but can be a bottleneck for CPU bound programs. Okay, so this means that even in a multi-threaded program, only one thread can execute Python code at a time. This is this is a well-known aspect of C Python. C Python is a Python with C interpreter. Okay, that is used for the standard implementation of Python. So purpose of GIL is like memory management. Okay, the primary reason is like memory management. Okay, to ensure that only one thread can run at a time. And second is simplicity and portability. Next is normally how does GIL works? Like GIL allows you to only make sure that there is only one thread to execute Python bytecode at a time. Okay, and even if program is running on a multi-core processor, this means that only one thread is executing Python code. All other threads are waiting for their turn. This is purely a Java multi-threading concept similar to Java multi-threading. Only one thread can run at a time when a program is going to execute. Okay. Next is so in summary, like GIL is a mutex in Python in C Python that allows only one thread to execute prime Python bytecode at a time. Purpose is like simplifies memory management and ensures thread safety. Performance is like it limits the performance of CPU bound multi-threaded programs. Okay, and yeah, and also like it uses multiprocessing native alternative Python implementation to achieve better concurrency. Okay. Next is how can you manage dependencies in Python projects? So managing dependency in Python projects is crucial for ensuring that your code works consistently across different environments and for different users. Now you can do it in different ways using pip like Python package installer from your terminal, which we like if you're using IDs like PyCharm or Visual Studio Code, you can run pip from your terminal, IDE terminal, and you can create a requirements.txt file. Okay, normally it's a standard way to list the dependencies for a Python project. It specifies the packages required for the version. So here, let's see, this is the file you have created requirements.txt. You can mention the package which you want. That's a Selenium, PyTest, behave you want, and you can mention the version on the right side. Okay, and then you can run the requirements .txt file. Okay, by running the command like pip install -r requirements.txt, then it will tell like if requirements are already satisfied or it is already installed, or if those of which are not installed, it will install automatically. Okay, you can do that. Another way is you can basically create your virtual environment, and there you can basically install packages. Okay, so these are the ways you can basically like manage your dependencies in Python. Okay, like best practices like using virtual environments. Always use virtual environments to isolate project dependencies and avoid conflicts within the system-wide packages. Okay, and you should update your dependencies regularly. Like regular update your dependencies to benefit from bug fixes and security patches. Okay, and we should use dependency management tools like pip env, poetry or conda to simplify dependency management and ensure consistent environments. Okay, next is what are Python built-in data types. Now some of the Python built-in data types are like numeric types, int, float, complex, sequence types, lists, tuple, range, text type, str, binary types like bytes, byte array, memory view, mapping type, dict, set types, set, then frozen set, boolean type, bool. These are some of the common built-in data types in Python. Okay, so and it provides a powerful and flexible foundation for data manipulation and processing in Python. Okay, next is like how can you read and write files in Python? This is a very common questions. Like if you should use an open function, open a file and specify the mode. Let's say R is for read, W is for write, A is for append. Okay, you should use that, and then use read function or as a read method or readline method or readliness method to read the content of your file. Similarly, when you're writing the file, you should use write rightliness methods to write the content in a file. Okay, you should start your function with a content with a with statement to ensure files are properly closed after their soup finishes. This is considered best practice as it handles file closing automatically even if exceptions are raised. Okay, so these are some of the basic questions we should uh, understand. Like normally a fresher should get this out questions. So let's move to the next question. What is a generator in Python? Very, very common question. A generator in Python is is a special type of iterator that allows you to iterate through a sequence of values. So normally Java and Python language bindings are have something common. So whatever you call in Java as the iterator is actually a generator in Python. Okay, generator in are the functions that run iterable sets of items. Okay, and the basic difference is that uh, you will find a yield statement in the generator. Okay, so let me tell the characteristic of generators. Like it's a lazy evaluation. Generators compute the values on the fly and yield them in one at a time, which makes it memory efficient. Okay, defined with yield. Generators are written with regular functions but use yield keyword instead of return to produce a series of values. Okay, and statement retention. Each time a generator next method is called, it resumes from when it left off. Okay, so these are the basic characteristic. You should use yield statement instead of return statement in generator. Okay, and it's a generator is a function that returns an iterable set of items. Okay, so in summary, benefits could be memory efficiency, improved performance, pipeline processing. In summary, generators in Python provides a very powerful tool for creating iterators in memory in a memory efficient, readable way. They are useful for handling large data streams, implementing lazy evaluations, and constructing data processing pipelines. Next question is, how does Python handle multiple inheritance? Multiple inheritance, like Python supports it by allowing a class to inherit from multiple classes. Okay, like in Java also, Python also has method overloading and overriding concept. So that also exists in Python, and it also has a concept of MRO, method resolution order. Okay, MRO is basically defined order in which base classes are searched when executing a method. So Python uses like a C3 linearization algorithm, okay, to compute the MRO. Okay, for example, if a derived class is calling the same method present in two superclasses, then Python will use MRO to follow the order and finds the method in the superclass one first. Okay, it means that if a derived class is calling same method present in superclass 1 and superclass 2, then MRO will follow the order and it will find the method from superclass 1. Okay, and another is like using super keyword, something which you have also seen in Java. It allows calling methods from the next class in an MRO, ensuring that in all relevant methods in the hierarchy are excluded properly. Okay, so in summary, multiple inheritance, Python supports it, allows a class to inherit from multiple classes, base classes. Method resolution order (MRO). Python uses a C3 linearization algorithm to determine the order in which classes are searched. Super keyword, it allows us calling methods from next class in the MRO, ensuring that all relevant methods in the hierarchy are executed properly. Okay, so that's how it basically works, and there is some similarity with Java also using super keyword, which also exists in Java, and method overloading concept is also there in Java, and MRO is like a concept that is uniqueness in Python, like it follows some kind of order in searching the method. Okay, so I think that's all into the session, friends. So if you like my video, please hit the like button. Thank you very much.